Alright, this is exercise 7D, question 7. That's our formula, the first formula we looked at for variance. And we need to show it's equal to that second form that we looked at for the formula for variance. And that one is an easier one to use in practice, although of course the calculator easier than any of them. Alright, here we go. We've got the original form of the formula. Now what we can do is expand the brackets. That's just expanding a perfect square, and we're going to get xi squared minus 2xi times mu plus mu squared. Now of course that's all still multiplied by pi. Now we can expand them. Brackets there again gives us xi squared times pi, and we note that's one of the terms we need, minus 2. Now I'm going to put mu in front, xi pi plus mu squared times pi. Now we can then break those terms up by looking at the sum of each individually. Minus the sum of 2 mu xi pi plus the sum of mu squared pi. Now some of those are constants, so they can come out the front, not in the first term. But over here we've got 2 mu. That can come out, that's a constant. Gives us the sum of xi times pi, and we should recognise that's the median. And over here we've got mu squared can come out, that's a constant, sum of pi. And we know that the sum of all the probabilities, because it's a valid probability distribution, the sum of all the probabilities is equal to 1. So that gives us the sum of xi squared times pi. Now here, minus 2 mu, that we know, I'll just change colour here. We know that that is equal to mu. So going back to black, that gives us 2 mu times by mu plus mu squared. And now again, we know that this is equal to 1. And so that gives us mu squared times by 1. So that gives us the sum of xi squared pi minus 2 mu squared plus mu squared. And I hope there's room. No. So you're going to have to just try to fit it in here. Equals the sum of xi squared times pi. Now minus 2 mu squared plus mu squared is minus mu squared, and that is what we want. Applause at the right spot.